On this video, we're going to simplify trig expressions. So we have secant x minus tangent x sine x. Well, if you want to simplify, you usually take out the common factor. But as you can see, you don't have any common factor. So what you're going to do is you want to change everything in terms of sine x and cosine x. So secant x is 1 over cosine x minus, what is tangent x? That's sine x over cosine x times sine x over 1. So you end up getting 1 over cosine x minus sine x times sine x, which is sine square x over cosine x. And notice you have a common denominator, which is, so you get 1 minus sine square x over cosine x. Now, if you remember the Pythagorean theorem of trig, sine square x plus cosine square x is equal to 1. And what is cosine square x? Well, if you move sine square x to the other side, you get 1 minus sine square x. And guess what? 1 minus sine square x is same thing as cosine square x. So using substitution, we get cosine square x over cosine x. Now what is cosine square x again? The same thing as cosine x times cosine x all over cosine x. You could cancel out the cosine x. As a result, you end up getting cosine x. Let's take a look at the next example. If you recall, secant x is cosecant of pi over 2 minus x, because they're cofunctions. So I could replace this part right here with secant x. As a result, you'll get negative secant x minus tangent square x secant x. Now, if you look at this terms, the common factor is negative secant x. And when you take out negative secant x, you'll get 1 plus tangent square x. Now, do you remember what 1 plus tangent square x was? Tangent square x plus 1 is secant square x. That's one of the Pythagorean identities. So now, replacing tangent square x plus 1 with secant square x, you'll get secant x times secant square x. So what is that? You'll get negative secant cube x. And that's what you get after you simplify the original. Before we simplify this expression, let's do a simple problem. Let's say you have 1 plus sine x, quantity 1 plus sine x squared. How do you simplify that? Or multiply that out? Well, you have to do FOIL. So you're getting 1 plus sine x plus sine x plus sine square x. And adding up the like term, you get 1 plus 2 sine x plus sine square x. So this is equivalent to that expression right there. You'll see why we needed to go over this before I do this example. Now, let's go back to this problem. What is the common denominator? Well, the common denominator is cosine x times the quantity 1 plus sine x plus cosine x times the quantity 1 plus sine x. Now, how to get from here to here? You need cosine x. So you got to multiply cosine x to the numerator. You'll get cosine x times cosine x, which is cosine square x. What about over here? How do you get from cosine x to this? You need quantity 1 plus sine x. So it's going to be quantity 1 plus sine x times quantity 1 plus sine x, which is quantity 1 plus sine x squared. Now, do you remember what we did earlier? We have to expand this. So as a result, you get cosine square x plus 1 plus 2 sine x plus sine square x all over cosine x times quantity 1 plus sine x. Now, do you remember what cosine square x plus sine square x was? That's right, it was 1. So now you get 1 plus 2 sine x over cosine x, quantity 1 plus sine x. This one we got by adding cosine square x plus sine square x. Now this becomes 2 plus 2 sine x. And the common factor will be 2, so when you take out 2, you get 1 plus 2 sine x. All over cosine x, quantity 1 plus sine x. I'm sorry, this has to be 1. Okay? Now, you could cancel this 2 out. You get 2 over cosine x. Now, this is correct. However, sometimes the book goes a little bit further. This is what I mean. 2 over cosine x is the same thing as 2 times 1 over cosine x. And what is 1 over cosine x? That's secant x. So it becomes 2 secant x. So sometimes the book might ask you to leave it like this if it's a multiple choice. Let's take a look at this example, cosine square x over 1 minus sine x. In order to simplify this, let's kind of review what this is. When you multiply this out, you'll get 1 minus sine x plus sine x minus sine square x. So when I say multiply these out, this is what I mean. And notice, this middle terms cancel out, you get 1 minus sine square x. Now notice, remember sine square x plus cosine square x equals 1. This is like the important theorem in trig. And from that, we know that cosine square x is 1 minus sine square x. So we could rewrite this as 1 minus sine square x over 1 minus sine x. Now, if you look at the numerator, this is a difference of squares. If you factor this out, you'll get 1 minus sine x, quantity 1 plus sine x, over 1 minus sine x. This cancels out, and you're left with 1 plus sine x. And that is your simplified form of this expression. Let's take a look at this example. You have 4 over secant x plus tangent x. In this case, you want to multiply by the conjugate, which means multiply the bottom by quantity secant x minus tangent x, and then multiply the top by quantity secant x minus tangent x. So notice what happens. Well, the top stays the same, but the bottom, when you multiply it out, you are going to cancel out the middle terms. So you end up getting secant square x minus tangent square x. Now, what do you do after you get to this point? Well, do you remember the Pythagorean identities? That tangent square x plus 1 is equal to secant square x. Do you remember that? Instead of secant x, we could substitute tangent square x plus 1. So you'll get 4 quantity secant x minus tangent x all over tangent square x plus 1 minus tangent square x. Because instead of secant square x, I substituted tangent square x plus 1. What happens here? Tangent square x cancels out. So you end up with 4 quantity secant x minus tangent x. And we simplified it.